Okay, so let's look over the sample exam 1, and we'll go over the answers for it. So the first problem, write the following without absolute value symbols as a piecewise defined function. Okay, so let's do that. Absolute value of x minus 2 plus absolute value of x. So first off, let me determine the critical numbers. To determine the critical numbers, I'll set each of x minus 2 and x equal to 0 and solve for x. So let me add 2 to both sides of my equation. So I get x is equal to 2, and I get x is equal to 0. So these are my critical numbers. Then I'll place those critical numbers on the number line. So the critical numbers are 0 and 2. Let me place those critical numbers on my number line. Let's say I put my number line here. So 0, and let's say 2. So I want to simplify x minus 2 in absolute value plus x in absolute value. And in each of these regions, they could possibly have differing expressions that represent them. And so let me calculate each of these in each of these regions. So if x is less than 0, then x minus 2 is negative. And so to take its absolute value, I have to put a negative in front of the x minus 2. Similarly, if x is less than 0, then x is negative. So I have to put a negative in front of the x. And so let's distribute the minus sign. And so I have a negative x plus 2 minus x. And so I get that this is equal to 2 minus 2x. Okay, let's do the same thing in the region from 0 to 2. Well, if x is greater than 0, if x is less than 2, then x minus 2 is again negative. If x is greater than 0, then x is non-negative. And so let's simplify this. So let me bring the negative inside. So I get a negative x plus 2 plus x. And so the x's cancel. And so I just get that this is equal to 2. Let's do the same thing in this region. If x is greater than 2, then x minus 2 is greater than 0. If x is greater than 2, then x is greater than 0. Oops. Why did I put a 2 there? That's x. And so I can get rid of the parentheses, combine like terms, so I just get 2x minus 2. And so I have that x minus 2 plus x is equal to two x minus 2 if x is greater than 2. It's equal to 2 if x is between 0 and 2. I will arbitrarily just make it equal to this value, 2 in the middle. I could put the equal signs anywhere. I could put it at the 2, but I'll just put it in the middle. And it's equal to 2 minus 2x if x is less than 0. And that is my answer. Let me go on to problem number 2. Given delta equaling absolute x minus 3, with delta greater than 0, of course, greater than or equal to 0, express the following in terms of delta. I'll just leave it as greater than 0. I mean, it could equal 0. It doesn't really matter, but usually when we do these in your later courses, delta is assumed to be greater than 0, even though it doesn't make any difference in this case. Notice that I can, so I want to express the following in terms of delta. This quantity, absolute, 3x minus 6 over 4. I can factor a 3 from the numerator. I can use the properties of absolute values. The absolute value of a product is a product of the absolute values. The absolute value of 3/4 is 3/4. And x minus 2, it's in terms of x minus 3. And so this is equal to, wait 1 second, let me give another little, so this is equal to, well, let me write x minus 2 as x minus 3 plus 1. And so this is equal to 3/4 of x minus, well, let's just say 1 plus x minus 3. However, since, actually, let's make this look a little different. Since x minus 3 in absolute value is delta, then x minus 3 is plus or minus delta. And so I'll have to sort of say that here. So that, and then that's my answer. And this is since delta equaling absolute x minus 3. This implies that x minus 3 without the absolute value is just plus or minus delta. And I just replaced x minus 3 by plus or minus delta. Okay, so let me do problem number 3. I can use this extra space here. Okay. And so let's simplify this. Well, I can factor out the lowest power of each of these that are in common. So the smallest power of 5x plus 3 is a negative 3 halves. So this is 5x plus 3 to the negative 3 halves. The smallest power of x plus 2 is x plus 2 to the negative 1 half. And so what remains after I factor this out is, well, let's see, the 5x plus 3 to the negative 3 halves cancel. The x plus 2 to the 1 half divided by x plus 2 to the negative 1 half, same as multiplying by x plus 2 to the positive 1 half. Since you have the same base, x plus 2, I add exponents. 1 half plus 1 half is 1. Now, 5x plus 3 to the 1 half divided by 5x plus 3 to the negative 3 halves, same as. I have the same base, so I subtract exponents. 1 half minus 3 halves, same as multiplying. 1 half, same as adding. 1 half plus 3 halves, 4 halves, which is to the power 2. The x plus 2 to the negative 1 halves cancel. And so I have that this is equal to x plus 2 to the first power plus 5x plus 3 squared, all divided by 5x plus 3 to the 3 halves, x plus 2 to the 1 half. So let me simplify this. So I'm just writing these negative exponents as positive exponents by bringing them to the denominator. So this is equal to x plus 2 plus, well, let's multiply out the 5x plus 3 quantity squared. So I get 25x squared plus 15 times 2 is 30x plus 3 squared, which is 9, all divided by 5x plus 3 to the 3 halves times x plus 2 to the 1 half. And so, let me simplify this. Good. So let's combine like terms. So this is equal to 25x squared plus 30x plus x is 31x. 2 plus 9 is 11, all over 5x plus 3 to the 3 halves times x plus 2 to the 1 half. And that is your answer. Okay. Let me do problem number 4. Factor the following. And so let's factor 3x squared minus 14x minus 5. Well, actually, that factors easily as 3x x plus 1 minus 5. And so I get 3x squared minus 15x plus x is minus 14x minus 5. Let me do problem number 5. Let me just move this up for 1 second. So problem number 5, reduce the following. So let's try to simplify this. 3 times the quantity 2x plus 3 quantity squared times 5x plus 7 quantity squared plus 9 times 2x plus 3 quantity cubed plus 5x plus 7 quantity squared, all divided by 2x plus 3 quantity squared, quantity to the fifth. Let us factor out what's in common in the numerator. Well, what's in common in the numerator is 3. There's also a 2x plus 3 squared, the lowest power, and that's got to be a cube here, and a 5x plus 7 to the power 2, since that's the smallest power. What remains? Well, the 3's cancel. The 2x plus 3 squares cancel. The 5x plus 7 squares cancel out 2 of the 5x plus 3, so all I have remaining is a 5x plus 7 is a 5x plus 7. 9 divided by 3 is 3. 2 of the 2x plus 3's cancel, so I just get 2x plus 3, and both of the 5x plus 7's cancel. I have, in the denominator, 2x plus 3 squared to the fifth, so that's a power of 10. And so this is equal to, I can cancel 2 of the 2x plus 3's. So in the denominator, I just get 2x plus 3 to the 8th. I still have a 5x plus 7 squared in the numerator. I have, well, a 5x plus 7 plus multiplying the 3 inside the parentheses, 6x plus 9. And so I finally get the following. This is equal to 3 times 5x plus 7 squared. Combine like terms, I get 5x plus 6x is 11x. 7 plus 9 is 16, all over 2x plus 3 to the power 8. And that is my answer. Let me do problem number 6. Simplify the following. 1 over 4 minus 4x plus 1 over 3x minus 1 plus 1 over x minus 1. And so, let me factor out 4. Let me factor out negative 4. And so I get x minus 1. Well, I can't really factor out anything here. So let me write this as 3x minus 1. And can't really factor anything here. So let me write this as x minus 1. Okay, so let me get a common denominator. The least common denominator is negative 4 times x minus 1 times 3x minus 1. So let me multiply and divide by negative 3x minus 1. So I'm going to have to multiply this by negative 4 times x minus 1, which is the same as, well, let's multiply the negative 4 inside the parentheses. So a negative 4x plus 4. And lastly, I have to multiply by negative 4 times 3x minus 1. Let me multiply the negative 4 inside the parentheses. So you get a negative 12x plus 4. Okay, so this is equal to, well, everything's all over the same denominator. Negative 4x minus 1, 3x minus 1. And so I'll write everything over the same common denominator. I have here a 3x minus 1, plus I have here a negative 4x plus 4. And lastly, I have here a negative 12x plus 4. So let's combine like terms. Let me move this down for 1 second so I have a little bit more space. Probably that. That's all I need. So this is equal to, well, the common denominator will still be the same. A negative 4, x minus 1, 3x minus 1. 3x minus 4x, negative x, minus 12x, negative 13x. Negative 1 plus 4 is 3, plus 4 is 7. And that is your answer. Let me do problem number 7. Simplify the following. And so I want to simplify this. Complex fraction. So let me multiply and divide by the least common denominator. You notice the least common denominator here of all the denominators is just x squared. So let me multiply and divide by x squared. If I do that, I'll get x squared minus 3x minus 10 over x squared minus x minus 6. I can factor this. This is a monic quadratic trinomial. So I'll factor it as x. Bring down the minus, times minus is plus. I want two whole numbers whose product is 10 and whose difference is 3, 5, and 2. Again, the denominator is a monic quadratic trinomial. So I'll bring down the minus, times minus is plus. I want two whole numbers whose product is 6 and whose difference is 1, so 3 and 2. And I will, I should say that I'll write the largest, the root with largest absolute value first, if I did that sort of dropping of those signs. And so this is equal to, well, I can cancel out the x plus 2's. So I get x minus 5 over x minus 3. And that is your answer. So let me do problem number 8. Divide the following. I can do that by synthetic division. And so let me do that. So setting x minus 1 equal to 0, I get that x is equal to 1. And so let's do some synthetic division. So I have 1x cubed plus no x squared plus 1x plus 0. I'll drop down my 1 times 1 is 1 plus 1 is 1 plus 0 is 1 times 1 is 1 plus 1 is 2 times 1 is 2 plus 0 is 2. And so I can write my answer. And so I have that this is equal to x squared plus x plus 2 with a remainder of 2 over the divisor x minus 1. And that is your answer. Let me do the same thing for problem 9. Let me do a synthetic division. So again, x minus 9 is 0. Adding 9 to both sides. So x is equal to 9. So let's do a synthetic division here. So I have 3x cubed plus no x squared plus 1x minus 1. Let's drop down to 3 times 9 is 27 plus 0 is 27 times 9 is 243 plus 1 is 244 times 9 is 2196 minus 1 is 2195. Okay, so now let's just write down the answer. And so we start out with a cubic, and so my answer will be a quadratic. There it is. And so my answer is 3x squared plus 27x plus 244 plus my remainder of 2195 over x minus 9. And that, is my answer. Okay, let me do problem number 10. Factor the following expression completely over the rationals. So I just want to factor this with rational expressions. This is quadratic. This is a monic quadratic trinomial in x cubed. So I can factor this as follows. So this is x cubed. Bring down the plus. Times minus is minus. I want two whole numbers whose product is 8 and whose difference is 7. So 8 and 1. Well, I can factor this because this is a sum of cubes. So I'll use the sum of cubes formula. The cube root of x cubed is x. The cube root of 8 is 2. X squared is, well, x squared. Change the sign. From positive to negative. Let's multiply x and 2 to get 2x. Will you stop? Okay, multiply x and 2, so it's 2x. Square the 2, so I get 4. Next, this is the difference of cubes. Cube root of x cubed is x. Cube root of 1 is 1. X squared is, well, x squared. Change sign from negative to positive. x times 1 is x, and 1 squared is 1. And that is my answer. I guess let me show that each of these, well, obviously the x minus 2s is factors as much as possible, and so is the x minus 1. Let me show that x squared minus 2x plus 4 and x squared plus x plus 1, that each of these are irreducible over the rationals. So let me show that. So I want to show that these are irreducible over the rational numbers. Okay. So recall the discriminant d b squared minus 4ac. So let's first look at x squared minus 2x plus 4. And I want to show that it's irreducible over the rationals. So let's look at its discriminant. A quadratic will be reducible over the rationals if and only if, again, well, I'll be assuming that all the terms in the original polynomial that I want to factor are rational numbers. Then a polynomial in Q will be reducible over Q if and only if the discriminant is greater than 0, greater than or equal to 0, and it is equal to a perfect square. And so let's look what this is. So I have b negative 2 squared minus 4a 1 c 4. And so 4 minus 16 is negative 12, which is less than 0. So my discriminant here I've shown is less than 0. And so if my discriminant is less than 0, then I know that this means that we have two unequal complex, well, non-real, maybe I'll say non-real, so they're complex roots. And so this means that, what was it? It was x squared minus 2x plus 4. So x squared minus 2x plus 4 is irreducible. Over the rationals. Okay, let's look at this other term, the x squared plus x plus 1. I'm going to show that that's irreducible over the rationals. So my discriminant is b squared minus 4ac negative 3, which is less than 0. Again, that just means that just like above, see if I can get control back at my screen. Okay. Okay, so since the discriminant is less than 0, this means that there are two unequal non-real complex. In fact, they're complex roots. And so this means that x squared, I think it was minus x, plus 1, no, plus x, is irreducible over the rationals. Therefore, what I wrote previously completely factored the original. There it is. So this is a complete factorization of my original polynomial over the rational numbers. Let me do problem number 11. Simplify the following. Okay, so let me do that. Let me get control back of the screen. Okay. So let's do this. Let me move this up. Okay, so 1 second. Let me move this up just a slight bit more. Okay, so this is equal to let me factor out the smallest power in the numerator, 5x plus 3 to the negative 3/2 power. Factor out the smallest power of x plus 2 in the numerator, x plus 2 to the negative 1/2. What remains? Well, I factored out all of the 5x plus 3 to the negative 3/2. Again, didn't we do this problem? No, I think we did something similar. X plus 2 to the 1/2 divided by x plus 2 to the negative 1/2 is just x plus 2 to the 2/2. 5x plus 3 to the 1/2 divided by 5x plus 3 to the negative 2/3 is just 5x plus 3 to the 4/2, which is 2, divided by 5x plus 3 to the negative 2/3. Okay. Give this a little bit more space. Okay, so now let me move these around a little bit. So let me bring this up. Yeah, let's do that first. Let's bring this up to the numerator. And so this will equal 5x plus 3. Now it will be to the positive 2/3 times the 5x plus 3 to the negative 3/2 times x plus 2 to the negative 1/2. Let me simplify what's inside. So this will be x plus 2. Squaring out this will be 25x squared plus 30x plus 9. Okay, so this is equal to. Let me rewrite. I have the same base. I'm multiplying, and so let me add. So let's get a common denominator. The common denominator is 6. So this is 4 over 6. And this is a negative 9 over 6. And so let's multiply these together. So I keep the same base, 5x plus 3, and I add exponents. 4 minus 9 is a negative 5 over 6. And I still have x plus 2 to the negative 1/2. Combining like terms, I have 25x squared, 30x plus x is 31x, plus 2 plus 9 is 11. Okay, so let me bring these down to the denominator. So I have that have a negative exponent. So I have a 25x squared plus 31x plus 11. Bringing this to the denominator, I have a 5x plus 3 to the power 5 over 6. Bringing the x plus 2 to the denominator, I have x plus 2 to the 1/2. And that is my answer. Okay. Let me do problem number 12. Rationalize the numerator of the following. And so I want to get rid of the radical in the numerator. And so to do that, let me multiply and divide by the conjugate of the numerator. Rad x plus h plus rad x. So let's multiply and divide by that. Okay. And so this is the product of the sum and difference of two terms. So I get the difference of their squares. The square gets rid of the square root. The square gets rid of the square root. All divided by the denominator h, rad x plus h plus rad x. So let me cancel the x's. What remains in the numerator is just the h. So rad x plus h plus rad x. The h's cancel. Oops. The h's cancel. So what remains is 1 over rad x plus h plus rad x. And that is your answer. Let me do problem number 13. Given the following sets, determine A intersect B cross B union C. So first let me determine A intersect B. So A intersect B is, well, what's in both A and B? 3. So the only thing in common is 3. Let's determine B union C. So what is in either B or in C? 1, 3, 4, 5, 6, 7. So that is what is in either B or C. Now let's try to determine A intersect B cross. So I'm going to take the Cartesian product, B union C. And so it's a set of all ordered pairs. So you take 3 as the first and any of the things here as the second component. So 3, 3, 3, 4, 3, 5, 3, 6, 3, 7. And that is my Cartesian product. Yep. Let me do problem number 14. I want to determine if the following relation defines a function. So to see if this defines a function, all I want to see is, well, does every x go to a unique y? Okay, and so let's see. If I look here, my input of 6 gives me an output of 7, but it also gives me an output of 3. So you want that any input, for any input, there's only one output. You don't want 3 outputs. And so since, 6 goes to 7, and since 6 goes to 3, then no, this is not a function. So no, this is not a function. So this set of ordered pairs does not define a function. Let me do problem number 15. Okay, so let me do problem number 15. Let's see if I can move this up. Okay. Good. An empty swimming pool can be filled in 10 hours. When full, the pool can be drained in 19 hours. How long will it take to fill the empty pool if the drain is left open? Okay, so 1/10 of since the swimming pool can be filled in 10 hours, 1/10 of it can be filled per hour. Next, since it can be drained in 19 hours. 1/19 of it is drained per hour. And so it's a negative 1/19 of it is filled per hour because you're taking away it being filled due to the fact that you can drain it completely in 19 hours. Next, we want to figure out if I do both of these things simultaneously, how long will it take to fill the pool? And so let me suppose it takes X hours to fill the pool. Then 1 over X of it can be filled per hour. Let me solve this equation. Well, let's multiply by the least common denominator, which in this case is 190x. And so let's multiply everything by 190x. 190x divided by 10 is 19x. 190x divided by 19 is 10x. 190x divided by x is 190. 19x minus 10x is 9x. Divide both sides of my equation by 9. And so you get 190 over 9 hours. So this is, let's divide this. This is going to be 21 and 1/9 hours. 21 and 1/9 hours. Let me write it like this. Now, let me write this in minutes. And so, this is 21 hours. And, well, there are 60 minutes in an hour. And so, if I take the fraction that's left, I get 6 minutes. And there are 60 minutes, 60 seconds in a minute. And so there's remaining 40 minutes, 40 seconds. And so I have that it takes 21 hours, 6 minutes, and 40 seconds to fill the pool. Let me do problem number 16. Maybe I should say that these are hours, minutes, and these are seconds. Okay, so let me do problem number 16. A piece of 12 inches on a side is to have 4 equal squares cut from its corners. If the edges are then folded up to make a box with a floor area of 64 square inches, find the depth of the box. Okay, so let me draw this. So this is 12 inches. This is 12 inches. We then cut out X inches from each of these corners. So now this is 12 minus 2x inches. And this is 12 minus 2x inches. You then fold it up and you get something here. Let's pull this down a little bit. So now, since it was folded up here, this length here is 12 minus 2x inches. Similarly, this side here is 12 minus 2x inches. And this height here is x inches. Okay, so let's try to answer this. Recall that the area find the depth of the box. So the area is 64 inches. Okay, so the area of a rectangle. Come on, please, give me back control of my screen. I want control of my screen back. I'm waiting for my screen to be able to get control of my screen. Still waiting. Still waiting. Okay, I have control of my screen again. So, if I have a rectangle, then the area of a rectangle is length times width. And so the area of its base here has to be 64. And so I have that the area of the base, well, it's a 12 minus 2x and another 12 minus 2x. And that's supposed to equal 64. Notice I can factor out a 2 from this first and a 2 from the second. Two times 2 is 4. Oops. That was a typo. And I have a 6 minus x squared. Divide both sides of my equation by 4. And so I get that 6 minus x squared is 16. So 6 minus x is equal to plus or minus 4. But since you only want positive areas, I'll just pick the plus. Okay. Let me get some more room here. So, well, actually, maybe what I'll do is, I'll wait one more second before I say that. Let me add x to both sides of your equation. And so I get x is equal to 6 plus or minus 4. So either x is equal to 10 or x is equal to 2. Okay. But if x is equal to 10, then you get 12 minus 20, which is negative 8. So that's impossible. So you can't actually have. Oh, let me do the following actually. Well, I could, okay, so in this case, the 10 doesn't make any sense. If I plug in 2, Well, that looks much better. Then it's just 12 minus 4, that's 8. So everything makes sense. And so 2 is fine. And so it says, find the depth of the box. Well, the depth of the box is 2 inches. Oops. So 2 inches. Okay. Oh, it's very hot. Okay. Then we do problem number 17. If a wagon wheel had 10 more spokes, the angle between the spokes would decrease by 360 degrees. Would decrease by 6 degrees. Suppose there are 360 degrees in a circle, which there are. So 360 divided by, let's say that there are X spokes originally. Okay. That's the angle of the little sector. Well, so if you had 10 more spokes, then the angle here would decrease by 6 degrees. Okay. And so let's solve that. So how many spokes, X, does the wheel have? Let's multiply by the least common denominator, X times X plus 10. The X plus 10s cancel, so this is equal to, and let me get rid of the degrees just to make it look nicer when I solve this. So the X plus 10s cancel, so you get 360X minus, equals, the X's cancel, so you get 360 times X plus 10 minus 6 times X plus 10. Let's multiply 360 negative 6X inside the parentheses. And so I get 360X is equal to 360X minus 3600 minus 6X squared minus 60X. Combine like terms, and so I get 360X is equal to a negative 6X squared plus 300X minus 3600. Let's bring the 6X squared to the left-hand side of my equation. Then 300X to the left-hand side of my equation, and the 3600 to the left-hand side of my equation. Divide by 6, so I get x squared plus 10x plus 600. Ooh, wait, that was a plus. That was a plus. this is a minus. Sorry, positive times positive is positive. And so bring it to the other side, you'll get a negative, which will be good. Then I can factor it. And so this is a monic quadratic trinomial. Bring down the positive times negative is negative. I want two whole numbers whose product is 600 and whose difference is 10. So 30 and 20. And put the root with largest absolute value first. And so x plus 30 is equal to 0, or x minus 20 is equal to 0. Subtract 30 from both sides. Add 20 to both sides. Well, you can't have a negative 30 number of spokes. And so, let me give a little bit more room here. Now these can have more than enough room, because this will be much shorter. Okay. So this says that there are 20 spokes. Okay. Let me do problem number 18. Determine the distance between the following points. Well, the distance between any 2 points by Pythagorean's theorem is, well, the difference in their x coordinates squared plus the difference, so a squared plus b squared, y2 minus y1 squared is c squared. So let's take the square root. So therefore, the distance between these points, call it, let's say that this is x1, y1, and this is x2, y2. So then this is negative 7 minus, I'm doing x's first, doesn't really matter. 4 minus the negative 2 squared plus negative 7 minus 3 squared. And so 36 plus 100 is radical 136. I can simplify that. And so let me factor out of 4 from the 136. 136 divided by 4 is 34. And so this is just equal to, trying to get control back while it's thinking. Okay, come on. Oh, okay, come on. Oh, will you cooperate? So this is equal to 2 rad 34. Let's do problem 19. Determine the midpoint of the line segment connecting the following points. And so the midpoint is just the average of the x coordinates, the average of the y coordinates. So let's call this x1, y1, x2, y2. And so the midpoint is just negative 2 plus 4 divided by 2, 3 minus 7 divided by 2. 4 minus 2 is 2, divided by 2 is 1. Negative 7 plus 3 is a negative 4, divided by 2 is negative 2. And that is your midpoint. Let me do problem number 20. Determine the slope of the line joining the following points: negative 2, 3, and 4, negative 7. So the slope, the formula for a slope going through 2 points is just the change in y, or the rise over the run. So this is just rise over run. And so the slope is, again, let's call this x1, y1, x2, y2. Okay. And so I get y2 minus y1 over x2 minus x1. And so I get a negative 10 over 6, which I can reduce to a negative 5 over 3. Maybe I should, well, I guess I'll have to write it down here. I don't have enough room. Well, m equals a negative 5 over 3. And that is your answer. I'll just squeeze it in right there. Okay, let me do problem number 21. Solve the following inequality and write the answer in interval notation. Okay, so let me put this into standard form. First, note that x squared plus 4x plus 4 is just x plus 2 quantity squared. Let me subtract 1 over x plus 2 from both sides of my equation, from both sides of my inequality. Let me get a common denominator. In this case, the common denominator is just x plus 2 squared. So I don't have to really do anything here. But here I'm going to have to multiply by an x plus 2 and divide by x plus 2. And so I get the following. So I have a 6x squared plus 1, multiply the negative 1 inside the parentheses, so negative x minus 2. I want that to be greater than or equal to 0. And so this is just 6x squared minus x minus 3, minus 1 over x plus 2 quantity squared. And that has to be greater than or equal to 0. Okay, so let me get some extra room here. I can factor the 6x squared minus x minus 1. I'll make this 3x, 2x. I want a minus, so that's a plus 1 and a minus 1 over x plus 2 quantity squared. And let's check if I factored it correctly. 3x times 2x is 6x squared. 3x times negative 1 is negative 3x. Plus 2x is a minus x. 1 times minus 1 is minus 1. So I factored this completely. So it's now in factored standard form. So let me try to determine my critical numbers. So I'll set each factor to 0 and solve for x. So I'm setting each of these factors to 0 and solving for x. So subtracting 1, dividing by 3, I get x equals negative 1/3. Adding 1, dividing by 2, x is 1/2. Taking the square root, subtracting 2, I get x equal negative 2. Okay, so let me draw a number line. Let me place each of these numbers on the number line. And so I have negative 1/3, positive 1/2, negative 2. Okay, that's a negative 2. And so I have here a negative 2. I should have looked to see if that was a big number or not. So it's a negative 2, negative 1/3, and positive 1/2. Okay, so pick a number greater than, actually I won't have any room here, so let me go a little further down. Pick a number greater than 1/2, say 1. Positive, positive over positive is positive. Pick a number less between negative 1/3 and positive 1/2, 0. Positive, negative, positive is negative. Pick a number between negative 2 and negative 1/3, negative 1. Negative, negative over positive is positive. Take a number less than negative 2, let's say negative 3. Negative, negative over positive is positive. We want this to be, and good. I want this to be greater than or equal to 0. So I fill in every critical number found by setting the numerator to 0. And so, good, it's back. And so I fill in every critical number found by setting the numerator to 0, but not the denominator to 0. So this will be left open. And then I will fill in all the pluses because I want this to be greater than or equal to 0. So let me do that. Okay. I guess maybe I can't select this. It's thinking. Okay, so I'll just leave it like this. Okay, I'll just use this one. So fill in the plus. Okay, fill in the plus. Okay, good. So my answer, I guess we want to write my answer in interval notation. Let me move this down so I can write my answer. And so my answer is negative infinity to negative 2, the open interval, negative infinity, negative 2, union, the half open, half closed interval, from negative 2 to negative 1/3, union, the closed interval, from positive 1/2 to positive infinity. And that is your answer. Let me do problem number 22. And so, solve the following inequality and write the answer in interval notation. So it's the absolute value of x plus 2 less than or equal to absolute value of x plus 1. I can do this in one of two ways, I guess. And so let's do it this way. Let's subtract x plus 2. Well, maybe I'll just leave it in this form. I'll leave it like this. I'll just leave it like this and say determine critical numbers. And so, to determine my critical numbers, I'll just set each of those equal to 0. Actually, I'll do it this way. Okay, so let me subtract the absolute value first. That might be easier to explain. So let's subtract absolute x plus 1 from both sides. Oops, less than or equal to 0. Okay, so now let's determine my critical numbers. So I'll set each of these equal to 0 and solve for x. So x is equal to negative 2, subtracting 2 from both sides, or x is equal to negative 1, subtracting 1 from both sides. Let me now place those on my number line. Okay, try again. And so let's put negative 2, negative 1 on my number line. And let's try to simplify x plus 2. I think I need more space here, actually. Try to simplify x plus 2 in absolute value minus x plus 1 in absolute value. Okay. If x is less than negative 2, both x plus 2 and x minus 1, x plus 1 are negative. So we'll have to change the sign for both of them, distributing the negative inside the parentheses. I get negative x minus 2 plus x plus 1. And so the x's cancel, and I get negative 1. Okay. Let's simplify. X plus 2 in absolute value minus x plus 1 in absolute value. Take a number between negative a half and negative 1. And so this is equal to, well, you know, positive. But this is going to be negative in this region. The x plus 1 will be negative. So you'll have to change that to a plus. Let's combine. Okay, please give me back control. Waiting for control of my screen. Waiting for control of my screen. Okay, so there's a dialog box that has come up, and it is not allowing me control back of my screen. I'm still trying to get control back of my screen. I'm still trying to get control of my screen. Just give me back control. Let's see if I can move this dialog box out the way. Okay, so while it's doing its thing, I'll see if I can draw. Okay, good. I can at least draw while it's doing this. And so I can get rid of the parentheses. So I get 2x plus 3. And lastly, let me look at this difference of these absolute values in this region. And so yeah, whatever. Okay, so oh my goodness. I'm trying. It obviously is taking control of my screen from me continuously. Okay, let's see if I can get back control of the screen. Thank you. So take a number greater than negative 1. So this will be positive. This will also be positive. So I don't have to change signs. So we get x plus 2. Let's distribute the negative inside of the parentheses. So minus x minus 1. And so the x's cancel. And I just get 1. Okay, so I have that x plus 2 in absolute value minus x plus 1 in absolute value is just equal to, let me bring this down for a second, 1 if x is greater than negative 1. It's equal to 2x plus 3 if x is between negative 2 and negative 1. And it's equal to negative 1 if x is less than negative 2. Okay. And I want that this inequality is less than or equal to 0. Okay, so let me give some extra room here for this last part. So x minus x plus 2 minus absolute x plus 1 being less than or equal to 0. Well, this is certainly true. It's certainly false if x is greater than -1, and it's certainly true if x is less than -2. But I want to see when it's true for values between -2 and -1. And so this implies that 2x plus 3 has to be less than or equal to 0. And less than -1. And x is less than or equal to -1. Otherwise, this is not going to be a true statement. Okay, so because if it's greater than -1, then it's greater than 0. Okay, so subtract 3 from both sides of my inequality. Divide by 2. Well, automatically, x is less than, x being less than or equal to -3/2 means that x is less than -1, since -3/2 is less than -1. So this says here that x is less than or equal to -3/2. And so I want to write this in interval notation. And so this is the half open, well, it is the closed interval from -infinity to -3/2. And that is your answer. Let me do problem number 23. Solve the following equation for x. Okay, so let's try to factor this. Well, this factors into 3x plus 5, x plus 1. And let's check. So 3x squared plus 3x plus 5x is 8x plus 5. Set each factor to 0 and solve for x. Subtract 5, divide by 3, subtract 1, and so either x is equal to -1 or -5/3. Let me do problem number 24. Solve the following. So let's solve the following equation for x. Let me multiply x squared inside the parentheses. So I get x cubed minus 3x squared equals -4. Add 4 to both sides of my equation. Let me factor this by grouping. So let's write this as x cubed plus x squared minus 4x squared plus, no, let's do minus 4x plus 4x plus 4. Okay, so notice, actually maybe I'll group this way. Okay, so notice this is just 0x, so I didn't do anything here. This is just a minus 3x squared, so I just rewrote that. So now let's regroup these. So again, factoring by grouping is sometimes an art rather than a technique. So I'm adding and subtracting these strange things so that I can factor by grouping at the end. So this is x cubed plus x squared minus 4x squared plus 4x. These both had minus signs, so I can factor out the minus. Plus 4x plus 4. Let me factor out what's in common in each of these groupings. So x squared, what remains is x plus 1. Minus 4x, what remains is x plus 1. Plus 4, what remains is x plus 1. Okay. Factor out what's in common, x plus 1. What remains is x squared minus 4x plus 4. Let's factor x squared minus 4x plus 4. That's a perfect square trinomial. So it's x minus 2 squared. Let's factor. And so let's use the zero factor property. And so set each factor to 0. X plus 1 is 0. Or x minus 2 quantity squared is 0. And let's solve. Okay, so I'll just have to do this. So let's subtract 1 from both sides. So x is equal to negative 1. Subtract 2 from both sides. Add 2 to both sides. So take the square root. Then add 2 to both sides. So x equals negative 1. Or x is equal to 2. Notice that x equaling 2 is what's called a double root. Because, well, this is a square. So we really have 1, 2, 3 roots for this cubic equation. And that's how many roots we wanted. Let me do problem number 25. Probably about this much. Let's see if that will go up. Okay, let's move this up. Let's see if I didn't clash with it. No, that's exactly the correct amount. And one more second. Let me move the rest of it. Okay, so let me move this down. And so maybe I don't need this extra page, so I'll get rid of it probably. Okay, good. Okay, so I guess I'll get rid of this page here. Okay, so let me do problem number 25. The volume of a gas varies directly with the temperature. The volume, V, varies directly as the temperature and inversely with the pressure. That's called the temperature T and the pressure P. When the temperature of a certain gas is 330 degrees Celsius, and the pressure is 40 pounds per square inch. The volume is 20 cubic feet. Okay. So let's figure out what K is. Well, let's cross multiply. So I get 800 and then divide by 330. So 80 over 33. I cancel out the 10. So K is 80 over 33. So I guess I'll need that extra page. So I have that V is equal to K, 80 over 33. Find the volume. So let's find V when the pressure increases 10 pounds. So it increases from 40 to 50. So 10 pounds per square inch. And the temperature decreases to 300. Okay. And so I have that the volume is equal to 80. The temperature is 300. And the pressure increased to 50. Okay. So the 3 cancels with that 3, so that's 11. And then one of the zeros cancel. 80 divided by 5 is 16. And so this is equal to 160 over 11. And so the volume is 14 and 6 over 11 cubic feet. And that is your answer. Okay. Let me just check something for 1 second. That was problem 25. Let me do problem number 26. Solve the following equation for x. 8 over 2x minus 1 minus 3 over x plus 2 is equal to 1. So let me do that. So let me multiply and divide by the least common denominator, which in this case is 2x minus 1 times x plus 2. So the 2x minus 1's cancel. So you just get 8 times x plus 2 minus the x plus 2's cancel. So you just get 2 times 2x minus 1 equals, well, let's multiply the 2x minus 1 times x plus 2. And so multiply the 8 together, the 8 inside the parentheses, negative 3 inside the parentheses. So I get 8x plus 16 minus 6x plus 3 equals 2x squared. 4x minus x is 3x minus 2. Combine like terms. And so 8x minus 6x is 2x. 16 plus 3 is 19 equals 2x squared plus 3x minus 2. Subtract 2x from both sides. Subtract 19 from both sides. And so I get 2x squared plus x minus 21 equals 0. Factor. This factors into 2x plus 7 times x minus 3. Set each factor to 0 by the zero factor property, and solve for x. So either x is equal to a negative 7 halves or x is equal to 3. When x is equal to negative 7 halves and when x is equal to 3, I'm not dividing by 0. So both of those are answers. So I have two solutions. Let me do problem number 27. Solve the following equation for x. X times x plus 5 equals 0. Well, the only way that this can be 0 is if the numerator is 0. So set each factor in the numerator equal to 0 and solve for x. So subtract 5 from both sides, so x is equal to negative 5. Notice when x is negative 5, I'm not dividing by 0, or x is equal to 0. And again, notice when x is 0, I'm not dividing by 0. Let me do problem number 28. I want to solve the following equation for x. And so I want that the absolute value of 8x minus 7 is equal to 9. Therefore, 8x minus 7 is equal to plus or minus 9. Add 7 to both sides of your equation. So 8x is equal to 7 plus or minus 9. Divide both sides of your equation by 8. And so x is equal to 7 plus or minus 9 divided by 8. And so let's simplify this. 7 minus 9 is a negative 2 over 8, negative 1/4. 7 plus 9 is 16 divided by 8 is 2. And so x is equal to negative 1/4 or x is equal to 2. So you have two solutions. Let me do problem number 29. I want to solve the following equation for x. So here I want to isolate one of the square roots, but notice that, well, I can't isolate both of them. So this is as good as I can do. So let me just square both sides of my equation. I'll at least get rid of one of the square roots, and then I'll have to do the same trick again to get rid of the second square root. So the square gets rid of the square root by the special product formula. I get this is equal to 1 minus 2 rad x plus 1 plus rad x, the square gets rid of the square root, so plus x plus 1. Combine like terms, so x minus 3 is equal to x. 1 plus 1 is 2, minus 2 rad x plus 1. Please note that it would be incorrect to cancel out the 2's because these are not like terms. Subtract x, subtract 2 from both sides of my equation. Square both sides of my equation to get rid of the square root. And so 25 is equal to 4 times x plus 1. Multiply the 4 inside the parentheses. And so I get that 25 is equal to 4x plus 4. Subtract 4 from both sides of your equation. Divide by 4. And now let's check that this works. Remember, you must always check your solution whenever you are looking at a radical equation where the index is even. This involves square roots, so obviously the index is even. So I have here, let's replace x by 21 over 4 minus 3. Is that equal to 1 minus, substitute for x, 21 over 4 plus 1. Okay, so let's see. And so, let's check. Get a common denominator, 4. So 21 over 4 minus 12 over 4. Is that equal to 1 minus, again, get a common denominator, 21 over 4 plus 4 over 4. 21 minus 12 is 9. Over 4. Is this equal to 1 minus 21 plus 4 is 25 over 4? Let's take the square roots. And so I have 3 halves is equal to 1 minus 5 halves. Well, no, that's not. Notice that it would be true if I changed the sign. So if one of the signs was changed, then it would be a true statement. And so I don't think it was an error in my algebra. I think it's just an extraneous solution. And so since this was the only possible solution, then this equation has no solution. Hopefully it'll get back my screen anytime. Okay, waiting for my screen. Okay, good. And so this says that my original equation has no solution. Okay, let me do problem number 30. Okay, and so let me try to solve for the radical, to isolate the radical on one side of my equation. So add 3, subtract x from both sides of my equation, square both sides of my equation. The square gets rid of the square root. And by the special product formula, this is 9 minus 6x plus x squared. Subtract x from both sides of my equation. Subtract 17 from both sides of my equation. Factor. This is a monic quadratic trinomial. And so I'll just bring down the x. Bring down the minus. Times minus is plus. I want two whole numbers whose product is 8 and whose difference is 7. And so, 8 and 1. Set each factor equal to 0. And solve for x using the fact that this is an integral domain. And so add x8 to both sides of my equation. Subtract 1 from both sides of my equation. Now I'm going to have to check if these are solutions. And so I'm going to have to check, let's see, if x is equal to 8 solves my original equation. And so let's replace x by 8. So it's 8 plus 17 plus 8 minus 3. Is that equal to 0? And so is the square root of 25 plus 5 equal to 0? is 5 plus 5 equal to 0? The answer is no, but notice that if I change my sign, it would have worked. So now let's check if x equaling negative 1 is a solution. And so, negative 1 plus 17 radical plus negative 1 minus 3, is that equal to 0? So let's check. Seventeen minus 1 is 16. Minus 1 minus 3 is minus 4. 4 minus 4 is indeed equal to 0. Therefore, my solution is x equaling negative 1. And that's it for today. And I guess, unfortunately, people got kicked off because of problems with the network.